Hello and welcome to day two. I have gotten a new computer since yesterday, so I'm hoping that the stream quality is going to be a lot better today. Let's go ahead and get started here. All right, let's see. Okay, so we are on 2022, day two. And I have not looked at it yet, so let's pull that up. Okay, day two is here. Rock, paper, scissors. The elves begin to set up camp on the beach. To decide whose tent gets to be the closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game based between two players. Each game contains many rounds. In each round, the players each simultaneously choose one of rock, paper, or scissors using hand shape. Then a winner for that round is selected. Rock defeats scissors, scissors defeats paper, and paper defeats rock. If both players choose the same shape, the round instead ends in a draw. Appreciative of your help yesterday, one elf gives you an encrypted strategy guide. Ooh, your puzzle input. That they say will be sure to help you win. The first column is what your opponent is going to play. A for rock, B for paper, and C for scissors. The second column, suddenly the elf is called away to help with someone's tent. Second column, your reason, must be what you should play in response. X for rock, Y for paper, Z for scissors. Interesting, okay. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, and 3 for scissors. Okay. The score for the shape you selected. Okay, plus the score for the outcome of the round. 0 if you lost, 3 if it was a draw, and 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were given the following strategy guide. AY, BX, CZ. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, A, and you should choose paper, Y. This ends in a win for you with the score of 8, 2 because you chose paper, and 6 because you won. In the second round, your opponent will choose paper, B, and you should choose rock, X. This ends in a loss for you with a score of 1 plus 0. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3 equals 6. In this example, if you were to follow the strategy guide, you would get a total score of 15, 8 plus 1 plus 6. What would your total score be if everything goes exactly according to the strategy guide? Okay. This is an interesting one. Okay, so first thing I'm going to do is I'm going to create a couple of files here. Oh, whoops, that was supposed to be a folder, not a file. That's why. Okay, yep. 2 And then, okay, so we'll say input.txt. We'll say example.input.txt and example.output.txt. So we already know that this is kind of our example here. So input would be that. And then our output for this is going to be 15. Okay, so, oops, 15. So I can, just from this, write a unit test for my solution to make sure that it passes the example input and output. Yesterday I didn't have the time to really show you kind of how I build my own framework around this just to make my life easier. I'll go ahead and do that today. Let's do index.mjs. And I'm going to do solve.mjs. Okay, this will have a function called solve where you pass it the input. And right now it's not going to return anything. I'm just going to return a 0. Okay. So this file I can use to coordinate like the inputs and all of the like checking to make sure it works and all that stuff. So I'm just going to say import from fs. We want to get read file sync. Okay, and then we want to import, no, I think that's all we need right now. So we're going to read file sync, very similar to yesterday. Read file sync, maybe we should create a function here for read file and pass in the name. And in there, we're going to read that file in. We're going to toString it. And that should give us the entire file contents. And then once we have the contents, again, we need to split it up. Each line is going to be one input. So we'll say const lines equals contents dot split. Again, using the regular expression, we may have a Windows user that created this input, so there might be a carriage return, but there will be a line feed. Okay, so that should split it up by lines. Another thing I like to do that I forgot before is just do a trim on the input after you read it. That way it doesn't matter if there's like a leading or trailing space on the input itself. Oftentimes I like to do that on each line as well. So I'll do like a map and I'll say line goes to line.trim. Okay, so this is kind of our return lines. So this is kind of like our boilerplate way of getting the input from a file and getting some lines created from it. So this is what we're going to do. We're going to have, let's do an array of, we'll say input is going to be example.input.txt and output is going to be example.output.txt. Oops. There we go. And then we'll have the real one that is input is going to be input.txt and output is going to be null. We don't know. Okay. Oh, and I just realized I didn't put this in the to folder. Yep. Let's move it over there. Okay. All right, so we want to run it against the sample as well as our actual file. So I'm going to say for each of these, and we'll just say test case. And we'll say we want to read the file. So we'll do the test case, test case.input. And that should give us our lines. So const lines equals that. And then what we can do next is we're going to export this function and we're going to take in the lines. So we'll say import from /solve, and we're going to import that solve function. Now we'll say const result equals solve and pass in those lines. And then we can say if there is an output for that output, that's great, output for that test case, then we are going to check to see if the result is the same as the expected result. Okay, so we'll say if test case.output, you know what, we need to actually read that output here. So we're going to say const output equals read file output, test case.output. And that's going to give us our output as a string array. We know that the output is only ever going to be one line, so we're just going to say at 0. Okay, so that should give us the line, and it should be trimmed and everything. Now, since different puzzles may have different outputs, whether it's numeric or alpha or other kinds of things, I'm not going to convert this to a number because I want to kind of make this reusable. So this is one of the few times that I would condone actually using the double equals in JavaScript, because in this case we don't care. The result may be a number, but the output is going to be a string regardless. So we're just going to say if result equals output, so we don't care about the type of it, it can do its type coercion. We're going to console.log output for, let's do example test case.input. So we'll say the file name is correct, and we'll put that output in parentheses here. So we'll just put the result. That makes it easiest. Okay. And then else, it's going to say incorrect. So basically what I'm doing here is I've just written a very, very basic unit testing framework here. Expected this, actual this. And we'll say expected test case, no, an output, and actual is result. Okay, with this alone, else. So if there isn't an output like there is for the real thing, we're going to just console log the result. Maybe we could make it a little bit. Output for the input file is we'll put it like this here. Okay. All right, we can go ahead and run this now. If I come to my terminal, I can go into that 2022 O2 folder, and we can say node index.mjs. And you'll see output, for example, txt is incorrect, expected 15, actual 0, and then the output for index.txt is 0. Of course, because we hard-coded the answer to the question there. So the cool thing about this is you only have to really write this code once. I might continue to enhance this a little bit by maybe scanning the directory, like read dir sync. So we'll say read dir sync, and I think we just put dot for current working directory. I don't see any reason I would try to run this from a different directory. Although, oh yeah, if I make this a common file, it will live outside. It would be like this, right? Yes. But that does create some interesting challenges here. So I want to read the directory from the current working directory. I'll run it from the O2 directory. Or maybe I could just pass in which directory I want to run it from. That's an interesting idea, but I don't think I want to do that right now. I want to get to solving the problem. But anyway, you could just iterate over those and do some extra work to kind of match up which ones are and aren't there. I've done that in previous years. Maybe I'll pull that in later in the month. But for now, this should work. And oops, oh gosh, I've broken it all. I'm not going to do that. We're doing index. Module not found. Could not find. Solve.m. Oh, it's not saved. There we go. Okay, let's get to actually solving this problem. So regardless of what programming language I'm using to solve the problem, I like to kind of pseudocode the solution first, so I can kind of just get an idea of what I need to do. So let's take a look at this. So first thing we need to do is parse the input into opponent, move, and your move. Okay. So once we've done that, we need to, well, there's a little bit more to it than that. So we basically need to, we'll just do split the line by space, and then map the first character and map the second character, oops, to whatever it is that we're going to represent this in. I like using objects. Some people just will, hard code the different letters and numbers and stuff into their code, and that's fine for if you're trying to speed run this or whatever. I try to give myself an opportunity during the advent of code to actually practice doing code in a good way, because practice makes permanent. That was something that my piano teacher always said. Not practice makes perfect, but practice makes permanent. The way that you code when you're practicing is going to be the way that you're going to code when it comes time for things to really matter. So here we're just going to go ahead. We're going to take care of parsing out the input. okay? And then I guess what we probably need to do is just kind of simulate. So score starts at 0. Walk through each of the rounds, I guess we can call it, and simulate the result and update the score, okay? And then at the end, you just add all of the round scores together. So I guess if we're doing it the way that I've pseudocoded it, we're just keeping track of it throughout. We're not like making rounds individually identifiable after the fact. So I think that should work. Let's give this a shot. So what we want to do, we've got a line. And just to remind us, the line is going to be something like this. So we're going to lines.map, and we're going to say for each line, we're going to make it L.split on the space character. That will give us an array of size 2 for each line, so it'll be a double nested array. I don't love working with double nested arrays unless we're working with like a grid or something like that. So I'm just going to go ahead and map it again and say we want it to be actually an object, and we will say opponent move is going to be L at position 0, and your move is going to be L at position 1. Okay, so that should give us objects, and we can run this now if we just do like a console log. Const moves equals that. Let's just see what that looks like when we run it. So you can see the 3 rounds. We've got ABC and YXZ. Is that correct? YXZ. Yep. But these symbols, they actually stand for rock, paper, and scissors. So let's go ahead and actually decode those ABC and YXZ values. We need some kind of dictionary for this. And so we'll just say const options, and we're just going to say if it's an A, then it's going to be rock. Is that what it was? Let's see. A is rock, B for paper, C for scissors. Paper and C for scissors. Okay, so we've got those options mapped, and we can say we actually want to, instead of just getting that part, we just want to map it into that dictionary that we just created. We can maybe move this down since it's starting to get kind of big here. Okay, and if we run that, let's see if that works. Rock, paper, and scissors. Great. Okay, so again, we can do the same thing. X for rock, Y for paper, Z for scissors. So we just duplicate this. X, Y, and Z. And since the keys for the 2 different options don't overlap in any way, I'm okay with doing this and not having it in a separate, you know, like their move options and my move options. Since there's no overlap, there's no reason to separate them out. So now if we do this, look at that. We've got actual rocks and papers and scissors. So So that's great. Now we need to actually do the logic. So we've done the parsing. That is all done. So I'm going to just kind of move this up above the code that we just did. Okay. So now that we've got the moves, we can run the game. Score starts at 0. We'll say let score equals 0. Okay. And then we can say moves dot for each, and we're going to say for each move we're going to simulate this result and update the score. Okay, so we need a way to figure out who wins between rock, paper, scissors. So we've got, a pretty finite number of options that can happen here. We could just go ahead and say something like if move dot opponent move. You know what, I don't want to have to type out the word move so much. I'm just going to make it a little more succinct. If move opponent is equal to rock, and move dot, I'm just going to make it U, equals rock, then we know that the outcome, so we'll say let outcome, we don't have one yet, but it'll be either a win or lose, right? So we know, oh, it's a tie. Now did it say, how did it work for a tie? Right, it's a draw. Okay, so win or lose or draw. Okay. So a draw, we can now say, okay, rock and rock is going to be a draw. So we could do that. Outcome equals rock. Draw. Okay. And we could duplicate this and say else if, it's paper and paper, it's also a draw. But really, at the end of this, you realize that there's kind of some common things. If your opponent's move is the same as your move, regardless of whether it's a rock or a paper or scissors, then it's going to be a draw. Okay? All right, so then that takes care of that case. Now we want to figure out all of the other winning cases. So else if m dot opponent is rock and m dot u is paper, then you know that you win, right? Outcome equals win, because paper covers the rock. Okay, let's see what other winning scenarios we have. M dot opponent equals paper, and m dot u equals scissors. So if you're holding the scissors, you can cut that paper, you win. Okay. Let's see what else. If m dot opponent is the same as scissors, and you have a rock, you can crush the scissors, and that is also a win. So the body of these three if statements are exactly the same. We could just chain these expressions together and make it a single if clause here. So let's go ahead and do that, just to reduce a little bit of duplicate code there. Again, I think that this isn't maybe necessarily my favorite way of approaching this problem. I'll bet that you could assign each of the values rock, paper, and scissors to some integer and then do a modulus, like adding the two together and taking a modulus, or doing some other kind of clever math type of way of doing this. But right now I'm not really thinking about that. So we've got our 3 win things here, and that's going to give our outcome the win. Now at this point, there's no other possible outcome that is not a loss. So we don't have to go through and duplicate this, but in reverse. We can just say else outcome is lose. So I'm going to just go ahead and do that. Okay, so we've got these 3 things here. And we can, I guess we can just remove the default value. It's always going to be assigned no matter what. All right, so maybe let's go ahead and just console log. Make sure that we're on the right path so far. Console.log outcome. Okay, run this. Win, lose, and draw. Is that what we expected here? So win, lose, and draw. Okay, so we're on the right track here. So next, we need to update the score. Now, just like mapping our ABC, XYZ to rock, paper, and scissors, I think we could map the scores as well. So let's create a mapping for the scores. So we'll say you get, let's see, scoring, okay, shape, so 1 for rock, 2 for paper, 3 for scissors. So rock, well, in JavaScript you don't need the quotes for a key. Rock is going to be 1, paper is going to be 2, scissors is going to be 3, and let's see, outcome, so we're going to put shapes, right? We could do this with like an enum or something, probably, if we were using TypeScript, but okay, so this will be outcomes. And so we'll say 0 if you lose, so lose 0. 3 if it's a draw. And 6 if you won. Okay, so win, I think is what I called it. Let's double check and make sure lose, draw, win. Lose, draw, win. Yep, okay. So we've got all of our scores defined here. So now we just need to calculate that score. So we'll say const round score is going to equal score of, no, it's scoring. I'm just going to call it scores. Okay, so I'll say scores at our at m.u, so that's going to be our shape, plus our scores at the outcome. Okay, let's console log those and make sure we're in the right ballpark here. So 8, 1, and 6, and 8, 1, and 6. All right, we are doing great here. So now we just need to increment the score itself. We'll say score plus equals round score. And at the end of the simulation, we just return our score. That's our answer. Okay, so now let's see output for example.input.text is correct, 15. Woohoo! We did it. And then input.text, I haven't actually pulled in my input yet. So let's see what our input looks like. Input.text, we've got 2,500 rounds. Dang. Let's run it for that, see what happens. 14375. Okay. Well, I'm feeling pretty good about this, but let's see. Woohoo! We got 1 gold star. Let's move on to part 2. All right, the elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. So those are the outcome you want, not the actual move to make. Okay, so that's interesting. So let's go ahead and not make the mistake I did first. Okay, so let's see here. Index. So here we want to actually have 2 functions, one for A and one for part 1 and one for part 2. So we'll say solve 2 and solve 1. Okay. And we'll do 1 and solve 2. Now this example is going to be specific to 1. So I actually want to rename this to example .1.input.text and example .1.output.text. Okay. And then we change this to solve 1 and put these .1 and .1. Let's make sure that we didn't break it. Still works. All right, so we can actually do something like this. If test case dot input dot includes dot 1 dot, then we know we're going to do solve 1. Else we're going to do solve 2. Okay. We can say let result equals. Okay, again, hopefully this will pay off the rest of the month when I'm not having to worry about any of this boilerplate and I can just run this. Okay, so let's look at what their example is here. So they're saying in the first string, okay, the example above now goes like this. So the example above is still the same. Sometimes they change the example in part 2, but not always. Okay, so we're going to say input.text, and the output here should be 12, which last time it was 15. So let's copy and paste that, and we'll say example 2 output is 12. Okay, so let's go ahead and add that to our thing here. So we'll duplicate this one. And you know what? We need to run our input against both A and B. I'll have to think about that later. I may just kind of hard code it for now. Whoops. So this will be example 2. Okay, cool. So for part 2, it was running solve 2, expected 12, actual 15. Great. So we've got a failing test. Let's go and fix it. So our solve 2, there's going to be some things that will be the same, like, well, this will not be the same. So maybe since these are no longer representing the same thing, I think I'll break this dictionary out into a separate dictionary. So this is going to be options, and we'll say const, let's call it desired outcome. And this is going to be, let's see, X is lose, Y is draw, and Z is win. Okay, so now that we've gotten those desired outcomes put together, we still have the same scoring, it says. The total score will still be calculated in the same way. And so let's see. Choose rock A. You need to end the round you need the round to end in a draw, so you choose rock. Right. Okay. So we already know the outcome, and we don't need to figure out the outcome as much as we need to figure out what shape will lead to that outcome. Okay? All right. Hold on just 1 second. I'm going to pause and help my daughter with something. I'll be right back. It says it's not compatible.
But I want to get it.
I can't get it for you. It's not compatible.
Oh,
Please go in the other room. We'll talk about it later. I'm streaming right now, okay?
I want this. Okay.
Okay, love you.
Love you. Love you. Love you.
And we're back. Okay, so instead of figuring out the outcome now, we need to figure out the shape based on the outcome. So we'll say, let's change this from moves to, we'll just call it round for now, I guess. Round. Okay, so we will say, instead of options, we want desired outcome. Okay. And we'll just call this outcome. Okay, so now we can just come and fix here any place that we have .u. We're going to change to .outcome. Okay, so we can't say that they're ever going to be the same anymore. So what we want to do is we want to figure out the three, so we'll have 3 branches in this here. One is going to be rock, one is going to be paper, and one is going to be scissors. Okay, so let's start out with something kind of more like this and kind of see what happens. Okay, so the opponent is rock, and the outcome is win. Then we know to beat rock, we need paper. So actually, we've got our paper case down here. Okay. Otherwise, if the opponent does paper and the outcome is going to be a lose. Oh, wait a minute. I didn't do the rock one correctly here. If we want a rock and a rock. That's going to be a draw. Okay. Paper for the opponent. We want to lose. That means we need to do rock so that the paper can win it. Right. Okay. And then finally, scissors. That's going to be our win because rock crushes scissors. So if we want to win and they have scissors, we need to do rock. Okay, we should be able to do the rest of these pretty easily here. So if they are doing rock and we are doing paper, we are going to win. Paper, paper is draw. And scissors, paper is lose. And again, I believe that we've already exhausted every other possible option by the time we get to this else block. We could put in the 3 cases for it, but I'm pretty sure that there's no possible way that we could get anything other than that at this point. Okay, so outcome, we're going to rename this variable because it's no longer win, lose, or draw. It's going to be our shape. So this is going to be rock or paper or scissors. Okay, so shape and shape, shape. All right, so now this should be easy enough. We're going to say the round score is the score of the shape plus the score of the outcome, which is m.outcome now. All right, let's see if it works with the test data. Oh no, not a number. That is distressing. Score is 0. Okay. I'm guessing that maybe something is coming out differently than what we're expecting. So shape is going to be assigned in one of those 3 things. M.outcome is win, draw, lose. Oh, have we not? No, we've got the win, draw, and lose. We've got rock, paper, and scissors. Maybe let's take a look at what the lines look like. And for now, I'm going to I'm going to comment out this one so we don't end up with tons and tons of output here. Okay, so after we have mapped the rounds, let's just console.log the rounds. I think it should be plural. That makes more sense to me. Okay. I mean, that looks like it got parsed correctly. So it's got to be something in the actual scoring that is causing the problem. So m_opponent, m.outcome. Okay, and we are using opponent and outcome. All right, so let's just console.log the shape now. Rock, rock, rock. Oh, is that really what they said? Choose rock. You choose rock. You choose rock. That's kind of funny. So rock, rock, rock. So the round score, so scores for the shape plus scores for the outcome. So let's console log each of those. And I'm going to show you a little trick that I like to do when I'm console logging multiple things out, is I'll just throw them into an object and I can say shape is shape. That's the shorthand. I can say shape score is going to be scores shape. and outcome score is going to be scores for m.outcome. Whoops. All right, let's see what that outputs. Rock, shape score, outcome score. Well, that's good to know. So score starts at 0. Score is being plus equaled by a round score. Looks like both of those are coming out as actual numbers. Return score. Huh. This is weird that we're getting nan. So let's do, actually, whoops. Like this, we'll also put in round score, and we will do score. And we'll just kind of watch it continue to evolve here. Score is 4, score is 5, score is 12. Output is correct. What? I didn't do anything but add this console log right here. Okay, let's try it again. Oh. So our solve 1 is broken. I was looking at the wrong line. So solve 2 is correct. Okay. I will fix that later, I guess. Let's just comment out 1 for now. It's confusing me. Okay. So let's try 10274 and see that if that works. Woohoo! Done. All right. So that's it. If you want to hang around, I will continue to hone this example script a little, or the test runner script, so that it meets my needs a little bit better and is more ready for the rest of the month. So let's say, so we'll bring in readDirsync again. And let's also process dot argv is a string array, and let's just console log that out for a second and see what we get. Whoops, I must have broken something somewhere. Where did I break it? There it is. Is it because of the trailing comma? I thought the latest version of Node didn't care about that, but maybe I am just too used to TypeScript. Can I read properties of undefined at line 6? Semicolon. Okay. Okay, cool. So we've got our args, and we've got the path to the file. So basically, I want to get the so the first one will be node, the second will be the path to the file. I want to move my file out here so I don't have to worry about it. So if I ran it out there, it wouldn't have the 2022 or the 02, but I could pass it in. So if I did something like this and did index.mjs, and we'll say 02. And so we could say, we're going to grab the argv. We know that 0 is node. So we'll comment this out. 0 is the path to node. 1 is path to script. And then after that, we have whatever the user passes in. So we could say 2 is going to be the day of the month, and we'll say 3 is the year. And we can default to the current year. just so I don't have to type 2022 all the time. But I could still go back or forward years theoretically and specify a custom year. Okay, so process.argv, we can say we'll say if not process.argv at position 2, then we will say, well, I mean, we could default that even to the current day. Defaults to current day. Let's do that. That way I don't have to worry about errors as much. I mean, there will be possibility of errors. But we could just say, okay, we'll say const puzzle equals, and we'll say day is going to be process.argv at 2, and default that to new date dot get day. Is that, but that's a day of the week, I think. Let's see. Get. Let me just double check this. I don't want to go down the wrong path here. So new date dot get day is 5, but it's the 2nd of December, but it's the 5th day of the week, so I was right. Gosh, what other options do we have? Get, is it date? Maybe it is just get date. Yeah, okay. I try to avoid using the JavaScript built-in date stuff when I can, because it's just not as intuitive as using libraries. Okay, so get date will be the default value, and we can say to string, and we can, I'm trying to remember in JavaScript, how do you pad left a number when you're or maybe, well, no, you can't just do like a format string like you could in .NET. Let's just do a quick Google. So we'll say JavaScript number pad left. Pad start. Oh yeah, that's right. That's right. Whoa. What? Yeah, so turn it into a string, and then you say pad start, how many digits you want, and the padding character. Yeah, that's right. Okay. So we'll just, let's see, here. We'll say toString.pad start with 2 and 0. Cool. So we should get 02, because I want them to land in the right order, because it's going to sort them alphabetically. Okay, so then year is going to be process.argv at position 3, otherwise new date dot get year full year dot toString. And we shouldn't need to pad that because I'm using the full year there in the folder structure. Okay, let's console log this out. So log puzzle. And I'm just going to comment out the rest of the file really quick so we can just kind of verify what's going on. Okay, so we'll say nodeindex.mjs. Cool, we've got that, but then we can also say I want to do 3, you know what? I'd love to be able to just pad the whole thing here. Let's do this. So we'll say, so we still have that working, and I'll say 3 would be 03. Nice. And 1 would be 01. And 24 would be 24. Okay, that's looking great. So I can basically decide which puzzle I'm grabbing based on that. So I will say const puzzle directory, and this time we're going to pull stuff from path, namely the join from path. Oh, whoops, join. So we're going to say join. We're going to join the year, so puzzle.year and puzzle.day. Okay, let's see. Cool. So now we could resolve this directory and say, we'll say read dir sync. Yeah, that's where I was going with that. Puzzle dir. And let's actually console log that really quick and see what we got. Uh-oh, it did not like that at all. Okay, so maybe let's join dot and then those. Let's try that. Scander 2022-24. Interesting. Oh. We don't want read dir sync on the first one. What is this returning again? So this is going to be, oh, it's still returning the same thing. Perhaps we could resolve this directory. So I think, is there a resolve in path, or am I thinking .NET? We do have a resolve. Okay, let's try this. Resolve the joining of those things. And that gives us, out of end of code, 2022. Oh, because we're on 24. Right. Perfect. That's exactly what I wanted. So we'll say if, and we can do a stat sync. Or actually, I think there's a exists in Node. Exists sync. Yep. Perfect. Existing sync puzzle dir. Then we are going to continue, but if not, we want to throw an error and bail out. So I'm going to say new error and say the directory for puzzle and we can just put the year dot year slash puzzle dot day does not exist. All right, let's try that. And now we get the actual error that we wanted there. Okay, so let's get rid of our argument there. And we've now got all of the files in that directory. So we will say const files is going to be this. We can say input.txt I want to keep the same, and solve.mjs I want to keep the same. So we'll say const input file is going to be input.txt, const solution file is going to be solve.mjs, and then we'll say const part1 files are going to be files.filter. We will say f goes to f.includes .1 dot, and part2 files are going to include a .2 dot. Okay. Right. All right, and then we want to reduce this so that we can have the input and output arrays or objects that we were mapping before. So we'll do a reduce, and again that turns an array into array of objects into a single object or value. So we'll say previous, current, and this time we're just wrapping them up all into a single map here, a single object. We're going to start with an empty object, and we're going to return that empty object every time. Well, it won't be empty by the time we're done. And we'll say let's see, part1 files. Right. So we'll say the name of it is going to be whatever's on the left of the first period. So we could have like example A, B, C, D, E, F. Sometimes they have multiple examples, and sometimes I want to try my own examples. So I'm just going to say, let's take the current, which is going to be our file name, like we have right here. We're going to split it on the dot. I'm not using a regex because that would just be everything. So this will be const parts, that, and we'll say const name is going to be the parts 0, and const type is going to be equal to parts at 0, 1, 2. Okay, so now we can say, and actually I think no, we'll do it as a mapped object here. So what we'll do is we'll say const existing, or well, maybe we'll say let example entry be equal to the previous file at the name of this current entry. And we'll say if there isn't one yet, because we'll start out with an empty object, example entry, then we want to create it. So we'll say example entry equals just an empty object. Okay. Then we take the example entry and we will set the type to the actually, we don't want to set the type. We want to set the key equal to its type. So for example, we want to have an input property and an output property. So by doing the index operator like this will allow us to say dynamically, okay, this type is an input, so we're going to go into this object to the input property. Cool. So we'll say that this is going to be type. And then we can say we'll set that object. Yeah, it'll be the same like that, equals example entry. Okay, so that's basically going to be exactly the same code as I'm going to do on the part 2 files. So I could actually just make this be, oops, let's see. Yeah, take this and just say const reduce examples, and that's going to equal that, and I can just say reduce examples whoops, reduce. Cool, and now I can do the same thing for part 2. Let's make sure I've actually gotten all of this right. So we'll say console.log. We're just going to do an object and put all of our variables into it. So we've got input file, we've got solution file, and we've got our part 1 files and our part 2 files. Okay, so if we run this now, okay, so we actually don't want just the type there. We probably want the entire file name. So we'll just say current instead of the part. Okay. And we'll run that again. Great. Now we've got example 1 input, example 1 output. Cool. All right. So now what we can do, we've got the part 1 files, part 2 files. Let's go back to what we had originally. So uncomment all that. This ends up being, we could just say, let's extract this out into its own function. We'll just call this const test equals this. So we will pass it a test case. It has an input and an output property on it, and this has an input and output property on it. So we will say maybe we want to tell it which one to use, solve 1 or solve 2. So maybe we say that the test case is going to be solve 1 for, yeah. Oh, this is getting a little more hairy here. Let's do this. Example entry is blank. So we'll reduce that, and then we will say so we're going to filter, reduce. Okay. And let's see, how do we want to pass in that thing? Maybe we just do it with, call this run, and we will say test cases and solve. Okay, there we go. So now we can just give it solve, and we can say test cases dot for each test goes to, and put this up into there. And then this becomes just test input, test output. Great. So we've got our run function. We don't need this anymore. We could actually just make this function run instead of making it an arrow function. That way it gets hoisted. We can put it at the bottom of the file. And we can put what we're actually doing up here. So we're going to say run part 1 files with solve1. We're going to run part 2 files with solve2, but we also want to run our actual input. So we're going to say run, we'll have input will be, what did we call it up here? Input file. Okay, and then, but we want to run it with solve1. And then we'll want to do the same thing for solve2. I think this might work. Let's see what I forgot. It blew up. Okay. Test cases.for each. Test cases. Oh, right, because I reduced it into a single object. So we'll say, I actually don't want to reduce it into an array then. But I do, in order to get the input and output to land on the same object. I guess I could just use find instead here. Just changes my code slightly. And we start with an empty array instead of an empty object. So we'll say our previous now is not going to be previous at name. We're going to say dot filter. E goes to e dot name equals name. But that means I have to put this name as name. Well, I can just do like that. Okay, so filter it, put it in there if it's not there. And then I probably need to just push it into the previous filter right here. And this line here, I'm just modifying the object, and so that will go into the array automatically. Okay, let's see if that works. Probably want to like, oh right, our solution file. We don't want to hard code that. But I'm running kind of low on time here. Can I get this to work with this one? So what's it complaining about here? We say test cases.for each is not a function. So test cases, where do we have test cases? Cases. We are passing it into run. Run should be an array. Part1 files should be reduced into an array. Let's just console log this out really quick. Console.log part1 files. See what I have in there. It's an empty array. Oh gosh, that's not great. Let's look at this again. So we're returning the previous array. Oh, this should be find, not filter. So find returns the first matching element, or null if it can't be found. But since I was doing filter, it was always returning empty array. Empty array is always truthy, which means this would have never happened, and it was always empty. Okay, so let's see here. Now we've got example 1, and example 1 output. Great. Okay, so now we need to figure out no such file or directory. Right, okay. So let's fix that by saying, so we got puzzledir here. So when we do our read file, we're going to join puzzledir and that. Similarly here, when we do this, we're going to join puzzledir and that. Okay, let's try it. Aha! It did not blow up. Great. Okay. So then the last thing that I need to do is get our solve functions dynamically instead of hard coding them. So what we can do here is going to be, let's do, right, so we've got solution file is solve.mjs. So we can say, let's read in, so we'll say await import join puzzledir and solution file, and that's going to be our module. But we can just say, we can deconstruct it as solve1 and solve2. Okay, and we'll say if not solve1 or not solve2, then we're going to throw an error. Could not find a solve1 and or solve2 function in this. There. Did that not work? Path argument must be of type string, received instance of object at promise.all. Interesting. What happened? Where is this at? Let's console.log. Maybe we'll say const solution file path equals join those two together. Let's console log that. And see what we have. Oh, it did not like that at all. What have I done? What have I done? Received instance of object, is it the join that's blowing up? Yes, it is. This should be puzzledir. Alright. Cool. Solve1 is not defined. Perfect. Let's fix that. And this will be solution file path. Import solution file path. And now we've got input.text is nan. That's still broken. I don't know why. That's kind of weird. Oh, let's just move this up here. Actual nan. And here we still have our solve1 export function solve1. Export function solve 2. Return score. Let's throw our console.log score back in here. Nan. Let's remove our input solve so we can see more clearly what's going on. Nan. Okay, what about round score? Nan. Okay. Scores. So those are good. What about outcome? Lose. Did I? Rock, paper, scissors. Scores. No, I didn't. I shouldn't have blown anything up there. That's weird. I'll have to go back and figure that out at some point. But I gotta hop. Thanks for watching, and I'll try to do this again at the same